Every year, farms across North Dakota and the nation suffer decreased yields and crop fertility because of nutrient deficiencies. This summer, the Dickinson Research Extension Center is investigating how different fertilizer application rates impact corn fertility and health. Dr. Chris Augustin, director of North Dakota State University's Dickinson REC, joins us today to explain what causes nutrient deficiencies, how they impact a plant, and how farmers can diagnose and treat them.
One of the things that happens during the growing season sometimes are nutrient deficiencies, and they have a tendency to pop up a lot of the time in June, and a couple of things are going on at that point. And one is we have moisture, or hopefully we have moisture. We have some heat, we have long days, and our plants are really starting to grow. So that's when those nutrient demands tend to be pretty high. But we have a spot here where on my left-hand side, it did not get nitrogen, and on my right-hand side, we did receive nitrogen. So we can see that there's a chlorotic or a yellow look to this corn, and the one on the right-hand side, it looks nice because it has sufficient amounts of nitrogen. And so when it comes to nutrient deficiencies, there's a couple of things we look for. One is, what does the symptom look like? Is it some slight chlorosis? Is there necrosis? Is it a leaf margin issue? Is it in the vein? Is it the whole leaf in general? But also, where is that location? Our macronutrients, nitrogen, phosphorus, and potassium, are plant mobile nutrients. So the plant is able to cannibalize those nutrients from older parts of the plant and translocate them to the newer parts of the plant. And so because those nutrients are plant mobile, the older parts of the plant may look sick, but the newer plants look good. Now we have plant immobile nutrients, which are most of our micronutrients. Sulfur is one of those. The plant is unable to translocate those nutrients. So we tend to see older parts of the plant looking healthy, and the younger parts of the plant, they're showing those symptoms from the nutrient deficiency. So in my left hand, we have a plant that I picked up from the nitrogen deficient area, and in my right hand is an area that was sufficient with nitrogen. A couple of things looking at the plants. Certainly with the nitrogen deficiency, we see this plant is more stunted than this one, and also there's a big difference in what the root mass is. But when we really look at it when you look at it from afar, this has a general chlorosis look, and this one has a nicer, darker green. Now, like I said, with plant mobile nutrients like nitrogen, the newer part of the plant will look healthy, and the older part of the plant will start showing those chlorotic symptoms. And so we go here to the newest leaf growing out of that whorl, and that doesn't look too bad. And we look at this older part of the leaf, it has more yellow to it. And so the nitrogen's being moved from here to over here. And so when we look at other plant deficiencies, our macronutrients in particular, phosphorus, we associate that with a purpling, as well as stunted root growth. Phosphorus plays a huge role in that. And with potassium deficiencies, I would be looking for this yellowing just on the leaf margins, not the entire leaf like we see here. We did some walking around with the plots, and this is that healthy corn again, nice and green throughout the entire plant. And I think I found a sulfur deficiency. Sulfur's plant immobile, so it can't take sulfur from older parts of the plant and move it to the newer part of the plant. So when we look at this plant, down here, some of the lower leaves, they look nice and yellow, but when we get up to these newer areas, they're starting to look chlorotic and have that nitrogen deficiency look across the entire leaf. But because down here it looks healthy and the new growth doesn't look as healthy, this is suggesting there's a sulfur deficiency. So we can go out and diagnose this. There's a couple of things we want to do. One is a soil test. The other is a plant tissue test. The problem with plant tissue testing is the numbers that were developed and we kind of use for concentrations, they were developed years ago. And our plant breeders have done a really good job of making a much more efficient plant. And so numbers from 50 years ago may not quite reflect with the numbers of today. So what we recommend is sending tissue samples of a sick area and then send in a second tissue sample from the healthy area. And from there you can compare the good from the bad and use that to help guide you on a nutrient rescue application if it's at the right time of year. If it's popping up later in the growing season, it might be too late to do that and just let the crop do its thing. But we also want to pair this with the soil test so we know what's in the ground from point A versus point B.
For more information about nutrient deficiencies, click on the link in the description below. And if you have any questions, please contact us using our website. We would also like to extend a special thanks to the North Dakota Corn Council for their generous support of this research trial.